Hi dear students, all of you, good afternoon. Welcome to Infinity Learn by Sri Chaitanya. Right dear students, in the earlier classes we've done vectors related videos. In this class, let me summarize the total 3D geometry in one shot. Right dear students? Yeah, coming to the point as like vectors. Hi Anshupriya. How are you? Right. Like vectors 3D is another important topic, easy topic from which you can get, you can easily score 4 marks or sometimes 8 marks. And most important, it is very easy to attempt a question from 3D, in advance from 3D geometry. Right friends? Yeah, let me give the briefing of this. As we have done vectors, that knowledge of vectors is going to help us even in 3D geometry also. Okay friends, right? The next one, just see, yeah. So the important points, the total 3D geometry we can divide into 4 parts friends. One is 3D coordinate system, means like 2D coordinate system. Fine Anshupriya, thank you. Hope the same with you. Right, okay. The second one is DRs and DCs. And the third one is planes. And fourth one is lines. Yes, these are the 4 topics that we have in 3D coordinate geometry. Right, in this friends, you know, so the easy things, that means very basic things I am not going to recollect because you know it. You know 3D coordinate system, each and every point in the space can be denoted in the form of a triplet x, y, z. That is point number 1. You know how to find the distance between 2 points. Am I correct? The first one is going to be distance formula. Just like in 2D geometry, here also we find the distance. The next one is section formula. Section formula in the sense, suppose in vectors kind of, suppose A bar, B bar are 2 vectors, you know how to find the point which divides AB in the ratio m is to n internally, externally, from which you can also find midpoint formula, right? The next friends, collinear points. Here mostly for collinearity, if 3 points collinear, the logic that we use here is you find DRs of AB, already you know, DRs of BC, they must be in proportion. That means A1 by A2 is equal to B1 by B2 is equal to C1 by C2 logic you apply. Next, coordinate plane divides a line segment in the sense, you see in the equation of xy plane is z is equal to 0, you know, because for every point in xy plane z coordinate is 0. Now what is the ratio in which a line segment joining x1 y1 z1 and x2 y2 z2 is divided by xy plane? Means the answer is minus z1 is to z2. In the same way, xz plane and yz plane. So that's what I have written. Coordinate plane divides a line segment in which ratio? Right? Already you know, if this ratio is positive, the division is internal, negative, the division is external. Right friends? After this, yeah, centroid. Already we have discussed, for a triangle centroid you can take like A bar plus B bar plus C bar by 3. If you treat those 3 points of the vertices, so you like 3 vectors, centroid of the triangle can be calculated by this. At the same time, centroid of the tetrahedron will also be. Tetrahedron means you will be given 3 points here and 1 point here. This is the tetrahedron. How to find the centroid? There will be 4 vertices. a bar plus b bar plus c bar plus d bar by 4 gives the centroid. Do remember here in tetrahedron, the line segment joining vertex and the centroid of the base triangle, if you take, let us name it as some median. So, the actual centroid divides this in the ratio 3:1 internally, fine, that is this point. Then locus related problems as usual. Suppose P is a general point, A is a fixed point. If PA is equal to 3, what is the locus? You just apply the condition, you will get some equation that is locus. This is not so important in 3D coordinate geometry here. Even translation of axis also not so important, but anyhow you know how to shift the origin to in 2D geometry. We see these are all the basic content, but the most important one is DCs and DRs of a line. Yes, you see friends, if any line, suppose these are the 3 coordinate axes, if you take a particular line, the angles made by the line with x, y, z axis respectively are alpha, beta, gamma, we call cos alpha, cos beta, cos gamma as the direction cosines. Even you can also take minus cos alpha, minus cos beta, minus cos gamma as direction cosines. The most important point, friends, listen to me carefully. So, generally we denote direction cosines by LMN. If these are direction cosines of a line, you can observe that L square plus M square plus N square is equal to 1. That is the thing. Any 3 numbers that are proportionate to direction cosines are called direction ratios. For example, friends, direction ratios are 1, minus 1, 3. Direction cosines you can prepare, divide with root of a square plus b square plus c square. This is 1 by root 11 minus 1 by root 11, 3 by root 11 can be called as DCs. You can also take with the opposite sign also. This is also fine. These are also DCs. So friends, if DRs of a line are given, you must be able to find DCs. If DCs are given, you can write the DRs. Right friends, this is the first and foremost important point in this particular page of subtopics what I have mentioned. Then friends, if 2 points are given on a line, say x1, y1, z1, say x2, y2, z2, fine. The DRs of this line is nothing but x2 minus x1, y2 minus y1, z2 minus z1. These 3 numbers are called DRs of the line. Yes, right. Now, if 2 lines are parallel, suppose there are 2 lines, say DRs A1, B1, C1, A2, B2, C2, the DRs, if the 2 lines are parallel, the condition is friends, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So do remember, DRs are, you can treat like a vector on the line. DRs means a parallel vector on the line. So they must be in proportion. If the 2 lines are perpendicular, you see these 2 vectors will be perpendicular, so dot product 0. The condition is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. This is very important concept, my dear students. Then how to find the angle between 2 lines? Just like if 2 lines are given, you find DRs, suppose these are the DRs, cos theta is like A bar dot B bar by magnitude of A bar into magnitude of B bar. Same logic you apply, you will get the angle between 2 lines. This is the preliminary information that you require about 3D coordinate system, and you can say DRs and DCs, right? Fine. Now friends, yeah, equation of a plane. You see friends, even though you are not aware of this, listen to this class carefully, you can understand. Equation of a plane in 3D geometry will be like ax plus by plus cz plus d is equal to 0. Do remember. In 2D geometry, if z term is not there, that is a line equation. Whereas in 3D geometry, this equation is equation of a plane. Do remember, this is not equation of a line. Many students will have confusion with this. This is equation of a plane. Okay, right. In here, A, B, C are going to be the normals of the plane. Do remember, if this plane, a line perpendicular to the plane you take, we call it as normal. The normals of this drs are going to be A, B, C. So this is first and foremost important point that you need to learn, right. Then friends, here we will be having, so we will be asked, what Anshupriya you are saying, cos of L1 L2 is equal to M1 M2 is equal to N1 N2. I do not understand what you have written. Cos is equal to, you have written L1 L2 is equal to M1 M2 is equal to N1 N2. What does it mean? That means L1 by L2. If L1 by L2 is equal to, so what is your question, Anshupriya? Can I please repeat your question? Yeah, meanwhile you give the question, I will be talking about this. So if it is the equation of the plane, then next in the upcoming problems we are going to see how to find foot and image. Suppose a plane is given, from a given point how to find foot of the perpendicular, how to find image about this, and all the concept we will be having. So the ratio in which a line segment AB is divided by the plane, normal form of the plane means this itself, perpendicular distance from point to a plane, intercept form of a plane means if x intercept is A, y intercept is B, z intercept is C, it will be in this format. Then angle between two planes, we define angle between two planes as angle between their normals. Suppose this is plane 1, this is plane 2, angle between their normals is nothing but angle between the two planes. Yes, okay. Now even in the same case, even in straight line also, how will be the equation of a straight line? I think you know, angle between two lines. Okay, right. So we come here anyhow that concept has come. You see, equation of a straight line passing through the point say x1, y1, z1 with drs abc will be like x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Friends, equation of a line will be like this. Do remember. So this is called the symmetric form of equation of a line, and here this x1, y1, z1 denote a point on the line, whereas ABC denotes the drs of the line, okay, So as you said, Anshupriya, if there are two lines with drs, suppose here first line drs a1, b1, c1, second line you are given like say x1, x minus x2 by a2, y minus y2 by b2 is equal to z minus z2 by c2. Okay. Now how to find the angle between these two lines? Simple, its drs are a1, b1, c1 and its drs are a2, b2, c2. So the angle between these two lines means cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Suppose, I think according to you, I think if you convert these as DCs, then automatically denominators will become, this is 1, this is 1. So you will get cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. If these are DCs, if DRs, you have to write like this. Okay? Okay? Fine? Right. The next, friends. So after this, did you get Anshupriya? Do you understand? After this, we will get problems based on what if two lines are coplanar, how to find the point of intersection of two lines, how to find the distance between two parallel lines, point of intersection kind of, shortest distance. Yesterday we have discussed related to vectors, the same thing between the skew lines, distance between two parallel lines, foot of the perpendicular and image of a point onto a line, length of the perpendicular from point to a line. So friends, these are the subtopics, various kinds of, but all based on 4-5 concepts only. If you understand the equation well, it is not a big thing to calculate, very easy things, dear students. Okay, let us take up some problems and try. Okay, fine, because if you discuss the problems, you will get more clarity. So equation of the plane through the midpoint of A and B and perpendicular to AB. Listen to me, friends. I want equation of a plane. Okay, plane equation will be like this. Through the midpoint of join of this, A is 4, 5, minus 10, B is minus 1, 2, 1. What is the midpoint, dear students? The midpoint is 3 by 2, 7 by 2, minus 9 by 2. This is the midpoint. And perpendicular to AB, our plane must be perpendicular to AB, means A is here, B is here, through the midpoint it has to go. You see, find the DRs of AB. 4 minus of minus 1, 5, 5 minus 2, 3, minus 10 minus 1 is minus 11. So I know the DRs of normals to a plane. Now you can write the equation of the plane in one stroke. You see, 5x plus 3y minus 11z is equal to, now this, because normal DRs are known, now it has to pass through this point. Substitute this point. This is 8 by 2 plus 9 by 2 plus 121 by 2, my dear friends. This is 138 by 2 you are going to get. You just see, friends, you will get. You see, through this you have to substitute. Yeah, 5 into 3 by 2 means 15 by 2 it is. Yeah, you have to substitute this point. So, yeah. So, because this plane is passing through this point. Yeah. You see which point? 3 by 2. You substitute 15 by 2. 7 by 2 means 21 by 2 plus 9 by 2 means 99 by 2. Yeah. Now you will get the answer. You see the same format, you see clearly C option is not the answer. A, B, D are of same kind, is equal to some positive number will be. So A is not the answer, D is not the answer. So I think, yeah, is equal to some positive number will be. So you just see, compute this, 120, 135 by 2 is equal to 135 by 2 is the answer. This is the answer, right, friends? Yeah. So we have found equation of a plane when a point on it is given and normal DRs are given. Next, friends, you see this question. The foot of the perpendicular from 0, 0, 0 to a plane is 1, 2, 3. Then the equation of the plane, same logic, no? You see, friends, foot of the perpendicular from 0, 0, 0 to a plane is 1, 2, 3. So now you know a point in the plane and normal DRs are known. Normal DRs are 1, 2, 3. 1, 2, 3 kind of, this is not the answer, this is not the answer, this or this. You substitute 1, 2, 3, you will get a positive number. B is the answer. That's it. That's it. You can easily do this problem. Next, you see vector oriented question, the ratio in which this plane divide the line segment joining the points. Friends, the plane is nothing but x minus 2y plus 3z minus 17 equal to 0. You call it as plane pi. Okay. Suppose first point is minus 2, 4, 7. Second point is 3 minus 5, 8. The ratio in which it is dividing is minus pi 1, 1, 1 is to pi 2, 2, 2. That means minus you write, substitute the first point is to substitute the second point. You will get the answer. Very simple question. Am I correct, friends? Yeah? Yeah. Clear? That's it. I think computation you can do easily. Next. You see the normal form of this particular plane. Normal form means, friends, it will be like x cos alpha plus y sin alpha plus x cos alpha plus y cos beta plus z cos gamma is equal to p, some positive number it should be, where p is the perpendicular distance from origin onto the plane. What is the perpendicular distance from origin onto the plane? Or else you just prepare, you just maintain DCs. DCs of this means DRs are 2 minus 2, 1. So DCs means I need to divide with root of a square plus b square plus c square, which is 3. So divide with 3, you will get 2 by 3 into x minus 2 by 3 into y plus 1 by 3 into z is 5 by 3. That's all. That means the coefficient must be in the normal format. That's it. Option D is the answer. A simple question, right? Clear? Next, the equation of a plane parallel to this at a unit distance from origin. Just like you see, plane's topic will be just parallel to straight lines topic in 2D geometry. A plane parallel to this means this part same, x minus 2y plus 2z is equal to some number, and distance from origin must be 1 unit. Distance from origin means mod k by 3 is equal to 1, k must be plus or minus 3. So you just see 3 combination is only here, this is the answer. That's it. That's it. Simple. Next, friends. This plane meets the coordinate axis in A, B, C, then the centroid of triangle ABC. Yeah. Yeah, fine, okay, right, good. Yeah. If the plane, if the plane meets the coordinate axis in ABC, then the centroid of triangle ABC. Arey yaar, it is simple. Where will it meet x-axis? You see, means put y coordinate 0, z coordinate 0. This is going to be, put these two, this is 3003 by 7. That's all. Then in the same way, where will it meet y-axis? Means these two coordinates will be 0. This is going to be 3003 by 11. For the other point, you just put x0, y0, 3003 by 13, right? Centroid means x1 plus x2 plus x3 by 3. So 3003 by, that means by 3 means 1001 by 7. I think 1001 by 7 will be around 143, I guess. So because, yeah, so you can take out this option. Next one, 1000, same 3003 by 7 into 3 is the centroid. 3003 by 11 into 3, 3003 by this is 13 into 3 gives the answer. Clearly you see this is big number, then smaller, then smaller. So this is the answer, because denominator you see gradually increasing, value will be decreasing. So this is the only such option, A. That's it. Okay. You can do calculation or you can say directly also, dear students. Okay. Fine. Next, the angle between the planes. Nothing, almost. Angle between two planes means, you see friends, if two planes are like this, yeah, angle between them is defined as angle between their normals. So first plane normal is 2, 1, 1, second plane normal is 1, minus 1, 2. Okay, fine. Then friends, I can say that the angle between these two you can apply, no? Cos theta is equal to A bar dot B bar by magnitude of A bar into magnitude of B bar, which is friends 2 minus 1, 1, 1 plus 2, 3 by this is root 6 into root 6, 1 by 2. Cos theta 1 by 2 means it must be 60 degrees, pi by 3. That's it. Okay. You see, you can expect a question in the combination of these concepts. That is my point. So you sometimes direct questions are given undoubtedly. Sometimes he is giving a question in 3D geometry. You can observe all the PYQs. He will combine 2 or 3 simple concepts of 3D geometry. Yeah, the equation of the line passing through this point and perpendicular to the plane. Arey yaar, perpendicular to the plane means already normal DRs are 2, 3, 1. Passing through this point means minus 1, 2, minus 3. You choose the options. Normal DRs 2, 3, 1 are only here, and the point is minus 1, 2, minus 3. Perfect. That is the answer. Right? Clear? Next. Yeah, the angle between the lines, it is also same here. He has given two lines. That means DRs means a parallel vector on it. Here also a parallel vector on it. Find the angle between the two vectors with the DRs 2, 1, 2, 1, 1, 0. Okay. So just find the angle. Direct question. Next, if these two lines are coplanar, this is very, very important friends. Two lines coplanar, then K can be. You see friends, in a plane, first line and second line lie in the same plane. That means friends, first line point is 2, 3, 4. DRs are 1, 1 minus K. Second line point is 1, 4, 5. This is vector is K 2, 1. That's it. So now coplanar means 3 vectors coplanar means the det is 0, box is 0. So this is one vector here available, here second vector. You join these two, you will get a third vector. What is the third vector friends? 2 minus 1, 1, 3 minus 4 minus 1, 4 minus 5 minus 1, 1, 1 minus K, K 2, 1. You just apply this det is equal to 0, you will get, you may get a quadratic equation, you find the real roots. So from here itself don't conclude that it is going to have two roots, maybe imaginary roots you may get. So this is why, so you can't get 3 values, it may be 2 values or 1 value or no value. Okay, so you may get a quadratic undo. So 2 lines coplanar is very, very important. Then next, yeah, this is another important concept. If these 2 lines intersect, then K, very, very important. You can take the general point on the first line like 2t plus 1, 3t minus 1, 4t plus 1. You take it as S, you just write general point, S plus 3, 2s plus K and S, right. Yeah. If they intersect, there exists some unique T and S such that these 2 points are equal. So now here k is there, better you equate these two. 2t plus 1 is equal to s plus 3, 4t plus 1 is equal to s. From this, friends, you can say you just add 2 on both sides, you will get s plus 3, no, add 3 on both sides, s plus 3. So 2t plus 1 is equal to 4t plus 4. So 2t is equal to, you can say, minus 3, t is equal to minus 3 by 2. If t is minus 3 by 2, what is s? You just see minus 3 plus 1, which is minus 2 minus 3 minus 5. S is minus 5. Yes. So for these values, these two should also be same. Yeah. Yes. You substitute t is minus 3 by 2, minus 9 by 2 minus 1 is minus 11 by 2 is equal to s is minus 5, which is minus 10 plus k. So k must be 10 minus 11 by 2. Yeah, 10 minus 11 by 2, which is 9 by 2 is the answer. And this concept you will be questioned many ways. You see, you may be asked what kind of lines these are. These are parallel lines or intersecting lines or skew lines. That question will also be done, right? So you can also do this like, friends, suppose instead of k some number is given, you can take this number, right? Suppose you have substituted for this, if these two matched, that means they are intersecting lines. Suppose here itself, if this vector and this vector are parallel, that means proportion, you can say that those two lines are parallel. If not parallel, they can be intersecting or skew lines. You check the intersecting nature. If they are intersecting, fine. If not, then the third case they will be skew lines. Okay. Sometimes you may be asked to find the nature of the curves also. The next, friends, you see the distance of this point from the plane measured along a straight line. What a beautiful question. Distance of, yeah, this point 1 minus 5 9 from this plane, but means if he stops the question here, it is perpendicular distance, but he measured along a straight line, means there is a straight line x is equal to y is equal to z. In this direction you have to measure. This distance he is expecting, right? So its drs are 1 1 1. So its dr should also be 1 1 1. Now, friends, what you can do is you just find the general point here. You just find the general point here, kind of. You see, so you know you can find a line, no, drs are known, one point is known. That is, what is the general point? This is t plus 1 drs, t minus 5 and t plus 9. This is the point on this. Yes, because r bar is equal to a bar plus tb bar. Multiply the parallel vector with t and add. This is the general point on this line. For some value of t, this point lies in the plane. Substitute x minus y plus z. So 2t minus t is t. 10 plus 5, 15 is equal to 5. T is minus 10. That means this point is, you see, minus 9, minus 15, yeah, minus 1. This is this point. Once you know this point, you find the distance between this point and this point. Minus 9, minus 15, minus 1. So the distance is 10 square 100, 100, 200, 300. Root 300 is 10 root 3 is the answer. That's it. So finding the distance of a point to a plane, if it is perpendicular distance, we have direct formula. Rather, if it is a distance parallel to some line, means you have to do like this. Okay, friends? Yeah, in the same way I have incorporated few more problems also. The point of intersection of this line and the plane is, the point of intersection of this line and this line, I guess this is not the plane, and the planes means, and the planes I guess. This means friends, when two planes are given, you see this is called unsymmetric form of equation of a line. Then take the cross product. For example, I cap, j cap, k cap, normals are 2, 4, 3, 1, 2, 3. You just find friends, I cap into 12 minus 6 is 6, minus j cap into 6 minus 3 is 3, plus k cap into, you can say, 4 minus 4 is 0. So for the required line, DRs are going to be 6 minus 3 0, you can divide with 3, 2 minus 1 0 you can say. And what you require is, you need one more point on it. So then you make one of the variables passive, put z is equal to 0 in both the case. So find that point where z coordinate is 0. So friends, if z coordinate is 0, you will get two equations, 2x plus 4y is equal to 0, this is 2x plus 4y equal to 0. That means, I guess, yeah, this is, they are not going to intersect. Better you put x coordinate is 0. If you put x coordinate is 0, you will get 4y plus 3z is equal to 3, of course minus 3, here 2y plus 3z is equal to 0. You solve these two friends, 2y is minus 3, y is minus 3 by 2. If you put y is minus 3 by 2, minus 3, no, z is equal to 1. This is the point. Yes. For x is z is equal to 0, it is not okay. So I kept x is equal to 0. I got 1 point. You know drs of the line and 1 point on the line. You can write the general point on this line and general point on this line. Just now we have seen a procedure how to solve this. Right, friends? So in this way, friends, we can do few more questions. The rest of the things we will do in the next class. So 3D part, friends, you can just do all the model problems whatever I have mentioned, and just do previous year questions. All the models will be covered, which help you in solving the problems comfortably. Right, dear students? Thank you. See you. Bye.